Dealing with raw bytes may seem daunting at first, but with a bit of practice, thinking in bytes becomes almost second nature. Still, I find that often such low-level implementation details slow us down. You really want to build a prototype quickly, not to be caught up in binary arithmetic, even when it's as simple as what we saw in Demo 1. Personally, I find it more efficient for my own productivity to work at a high level, logical, rather than having to worry about the hardware too much. If your gadget qualifies the prototyping phase, you can always go back for a round of optimizations. So for this demo, I'll show you a way to abstract the way that data is written to and read from the EEPROM and a bit to speed up your personal productivity. We will make use of the EEPROM extended library. This library extends the one that comes with the IDE so that it knows about all the common data types that we are likely to use in Arduino sketches, not just the byte. With EEPROMex, if you want to store or fetch an integer or double, you just call the appropriate method and the job is done. No need to think about bits, bytes, and bit shifting. This abstraction and flexibility comes at the cost of flash memory. Adding the library adds a couple of kilobytes to your project sketch. Get the library from the GitHub repository, install it in the libraries folder, and start the IDE. The library is a drop-in replacement of the default EEPROM library, meaning that you can just replace one for the other and your sketch will still work. The extended library adds functions for longs, ints, floats, and doubles. You can also manipulate single bits, which is great for better managing storage resources, arrays, strings, C-structs, and it even provides an update function that checks if a new value already exists in the EEPROM before saving it, thus extending its lifespan. Well, doing binary arithmetic and shift left and shift right bits and then adding bits together to create original data types from components stored in EEPROM is fun, or sometimes it is, at least it is fun. But usually you'd want to avoid that if you've got more important things to do. So in this second demo, we're going to use the EEPROM extended library, EEPROMex.h, in order to gain the flexibility of storing data types without, on our part, having to do any bitwise manipulation directly into the EEPROM. So in these two sketches, I've got the exact equivalence of the sketches in Demo 1, with the difference now that I don't have to worry about doing binary arithmetic. So again, I've set my address where I'm going to store the integer. This is the same integer as before, 1234. Remember in the Arduino and ArtMega microcontrollers, an integer takes up 2 bytes in memory. Now, because I'm using EEPROMex, I'm going to use a slightly different version of the write function. It's now write int, and there's other types of write as well, depending on kind of data type you want to store in your EEPROM. So I want to store an integer, so I'm going to say write int, the address where I'd like this piece of data to go, and the value itself, the integer, my pin. That's it. So now I didn't have to worry about splitting this integer into its high and low byte. Just one command will do it. On the other side, the reader, again, I'm importing the extended version of the EEPROM library, set the address where I'd like to read the integer from, and here's I'm declaring a temporary variable to hold that integer. It will be read from the EEPROM, and this is where the reading is happening. I want to read an integer from the EEPROM, so I say read int, address 0 in our case. That will go get the integer from EEPROM, store it in my integer local variable, and then print it out. So a lot simpler than before. Let's have a look at these two sketches in action. Okay, so the pin was recorded. Let's read it. There you go. Read. Easy.